Hello, algebra students. Mr. Lawrence here with your quick factor check. This is the difference of perfect squares method, okay? Now remember, we have a perfect square minus a perfect square, and it's a subtraction problem. These are really easy to factor. So the first thing I do is I check, is x squared a perfect square? You bet your boots. And the square root of it is x. Is 25 a perfect square? It sure is. Square root is 5. Is it subtraction? Yes. So this will factor with two quantities. Two quantities, ladies and gentlemen. Two quantities. And they're going to be an x plus 5 and an x minus 5. The difference of perfect squares will always factor in this method. Always. If you have a perfect square minus a perfect square, it will always factor in this style. Or if you have the negative of a perfect square plus a perfect square, believe it or not, that's subtraction as well. Let me explain a couple more times. Let me go with number 2. Is 9x squared a perfect square? It sure is, ladies and gentlemen. The square root is 3x. Is 49 a perfect square? You bet your baloney. It sure is. Yeah, I know people don't eat bologna anymore. Sorry. All right, so we're going to get a 3x plus a 7, and we're going to get a quantity of 3x minus a 7. And oh my goodness, this is so easy. Now, I'm going to fool you on number 3. Is 25x squared a perfect square? Sure is. Is 100 a perfect square? Yep. Only problem is, you should always check for a GCF first. I didn't check for it on those, but there wasn't one. Here there is. The GCF is 100. It's not 100, Mr. Lawrence. It's only 25. So I'm going to factor out a 25. And watch what's going to happen. Inside, I'm going to have an x squared, which is a perfect square. And I'm going to have minus 4, which is a perfect square. This is going to factor further. It's going to factor twice. Isn't this amazing? We're going to have a 25 out front, and then we're going to have two quantities. Now, they're both perfect squares. The square root of x squared is x. Square root of 4 is 2. Then I'll have an x and a 2, and one of them will be positive and one will be negative, and there you go. All right, one more kind of like that. If I've got this negative in front, I'm probably going to rewrite it as 36 minus 16x squared, right? Because the negative belongs to the 16, doesn't it? And the positive belongs to the 36. The 36 is positive. Now I have the difference of perfect squares, except, you guessed it, there's a GCF hiding in here. I think it's 4. I'm going to pull out a 4, leaving me a 9, which is a perfect square, minus 16x squared. Oh, not 16x squared. I pulled out a 4, silly Mr. Lawrence. Minus 4x squared. And is that a perfect square? Yes, it is. So I'm going to have 4 times two quantities. And I'm going to have 3 plus 2x and 3 minus 2x. And look at that, I factored completely. Oh my goodness. All right, here's 3 problems for you to try. Go ahead and pause the video. If you're still watching, I'm assuming you've already tried the problems on your own. Just to watch again wouldn't do any good. You can't learn math by watching. It is not a spectator sport. You must get on the field and play. All right, I'm going to check for a GCF. 81x squared minus 36. I think a 9 is my GCF. I'm going to pull that 9 out. I pulled it right out of there. 9x squared minus 4. Oh my goodness, I have the difference of perfect squares. So it's going to be 9 times 3x plus 2 and 3x minus 2. All right, going to problem 50. Oh no, I don't have perfect squares. 50 is not a perfect square. 8 is not a perfect square. What am I going to do? I'm going to GCF, guys. Come on. I'm going to pull out a 2. I'm going to get a 25x squared. Look at that. It's a perfect square. 8. Oh, pull out a 2. It becomes a 4. Difference of perfect squares. All right, so I'm going to have 2, and there's going to be 2 quantities. 2 quantities, ladies and gentlemen. And my mouse is acting up. I'm going to get a 5x plus 2 and a 5x minus 2. And this is too frickin' easy. All right, C. Did I fool you? Did I? C's prime. Yeah. They're both perfect squares, but there's no subtraction. Difference means subtract. There's no subtraction. Maybe you thought it was this. Maybe you thought, well, if you double distribute to check your work, oh my goodness, I'm not even writing it down right. That's because it's late. It's like 10:30 at night, and I'm doing this for you, ladies and gentlemen, because I care so much about you, and I want you to learn well. When you multiply these two together, you're going to get a negative 16. You're not going to get a positive, so this cannot be the answer. Then you go, I know, it'll be this. You can't fool me, Mr. Lawrence. Tough, I fooled you, because you are going to get x squared, and you are going to get plus 16, but you're also going to get 8x. And see, there's no 8x in this expression, this binomial. So this is not the factored form of it. Okay, if you make them both negative, you're going to get a minus 8x. So this one is called prime. Okay, it is prime, meaning it cannot be factored. Now, when we do quadratics in a chapter or so, if we have to solve an equation that has this, like x squared plus 16 equals 0, we can go to the quadratic formula and find out if there is a solution. Just because it's prime doesn't mean we won't be able to solve it. In this case, we won't. But anyway, I digress. That's it for the quick factor check on difference of perfect squares. Have a good night, everybody.